Hi, in this video we are going to talk about the disadvantages as far as multithreading is concerned. So let's take a look at the disadvantages. Of course, as you may guess, there are some costs involved in multithreading, so multithreading is not always a better solution. So if you have the opportunity to make an application multithreaded, it's not going to be the best solution ever. Because threads manipulate data located on the same memory area, so we have to take it into consideration. Basically, this is why we are going to talk about synchronization. So we have to synchronize these threads in order to prevent data inconsistency. Then it's very difficult to design multi-threaded softwares, and it's very hard to detect errors. But basically what's very important, that the main cost, that there has to be some communication between the threads. So for example, when you want to share some variables between threads, then you have to use something called the callable and the future. We are going to talk about it later, but it's very expensive to communicate between threads. And another expensive operation is switching between threads. So why is it that expensive? Because every single thread, as we have discussed in the theoretical section, has a distinct memory location with its own variables, with its own cache, and so on. So whenever there's a switch between two threads, then the central processing unit is going to save the local data, the pointers and whatsoever of the current thread. Plus, the central processing unit has to load the data of the other thread. So that's why switching between threads is quite expensive. So using several threads, for example, thousands and thousands of threads, is not going to be that efficient, because of course you are not going to have as many processors as the number of threads, which means that there's going to be a central processing unit. It has to handle all the threads. So it has to switch between the threads from time to time, and it's quite expensive. So that's why if you have the intuition that using as many threads as possible is going to be a good solution, no, this is not true. Using as many threads as possible is going to lead to a very slow application and a very slow algorithm in the main. So a good rule of thumb, that for small problems it is unnecessary to use multithreading because it may be slower than single-threaded applications. For example, multithreaded sorting is slower for small number of items. I'm not sure whether you are familiar with sorting algorithms, but for example, merge sort or quick sort is going to be slower with multithreading if we want to sort, for example, 10 items or 20 items. A single-threaded implementation is going to outperform multithreading. Okay, but if we want to sort, for example, millions or billions of items, of course multithreading is going to be okay. So this is why I say that for small problems, usually we don't need any multithreading. Why? This is what we have been discussing in the previous slide, that switching between threads is quite expensive, so we have to avoid it. And another important fact, that the connection between the running time and the number of threads is something like this. If we have just a single thread, of course the running time is not going to be that fast because a single thread has to do everything. If we increment the number of threads in the given application or algorithm, the running time is going to be smaller. What does it mean? That the algorithm is going to be faster. Of course, there are an optimal number of threads running by that given algorithm, which going to yield the optimal solution. And then if we have several threads, for example 1,000 threads or tens of thousands of threads, then the running time is going to be huge. What does it mean? That the application is going to be very slow because of the communication between the threads. This is what we have been discussing. So what's very important, that for small problems we don't use multithreading at all. If we have a larger problem, or for example an application in which we would like to use, for example, input-output operations, downloading images from the web and so on, We can use multithreading. We can use, for example, 5 threads, but we don't have to use, for example, 10,000 threads, because then again the application is going to be slow. So there's an optimal number of threads that's going to yield the optimal solution. Thanks for watching.